Hello, my name is Nick Deborah, and in this short video, I want to talk about one of my favorite data visualization tricks, which are called inset charts. And so to introduce the concept, let's start with a kind of well-known data set. These are the 10 basically fastest humans in the world with their best 100-meter running times. Of course, Usain Bolt there at the top. And let's say we want to visualize this in a chart. So we decide, okay, well, let's try it in a bar chart. Well, you're probably looking at this and thinking, well, this is not very useful because it looks like all of these values are essentially identical, right? Well, we always want to come back to, asking ourselves, like, what is the purpose of this chart? Like, what is the job of the chart? And depending on that, this might be okay. Like, for example, if what we wanted to say was that these elite runners have extremely similar 100-meter times, then this chart actually communicates this insight very effectively, and we don't need to fix it. We don't need to change it. However, if we want to say something like Usain Bolt dominates the other elite runners in the 100 meters, well, then clearly this chart is not going to really cut it, right? We need to do something else. And so this is often where you'll see charts like this. This is called a truncated scale, right? Because we're starting the scale at something other than 0. And yeah, well, I can actually see this main message more clearly now. I can see that Usain Bolt is indeed kind of dominating. He's got much shorter times than the others. But there's a problem here, kind of a perceptual problem, which is that it looks like Usain Bolt's time is about maybe 2/3 of Tyson Gay's time, right? But that is clearly not the case, right? Usain Bolt did not run the 100 meters in 2/3 the time of Tyson Gray. And this is a problem because this is how we read bar charts, right? We compare the lengths of bars. And so a bar that is 2/3 the length of another, we perceive as representing 2/3 of the quantity, which is not really the case here. Sometimes you'll see solutions like this where people will use 2D position, i.e. in this kind of dot plot. And the theory being that because we have no lengths of bars to compare, we're not going to perceive Usain Bolt's time as being 2/3 that of Tyson Gray's. But in practice, I find that this doesn't really hold up in my experience. It's anecdotal, but this still looks like Usain Bolt's time is like much less than Tyson Gray's, but it's actually not, right? It's just, hundredths of a second apart. And so in a situation like this, where I want to feature the small differences amongst values that all fall within a narrow range, I'll use another technique called an inset chart. And so I start with a chart where the scale starts at 0 to kind of show the big picture. All these values are very similar, but then I'll add this inset chart, right? And so this then basically kind of gives me the best of both worlds, right? I can see, big picture overall, these values are very similar to one another, but I can also feature the small differences between them because that happens to be relevant in this particular case. Doesn't just work with bar charts. For example, we can have the same problem in a line chart where, again, all of our values fall within this very narrow range. And if I wanted to see, for example, well, during which months was our employee headcount above or below target, well, it was so stable that I couldn't really tell. And again, this may or may not be a problem. The main message of this chart was that, our employee headcount is very stable over time, then that's exactly what this chart says, and I don't have to really change it. However, if I wanted to feature small differences, from one month to the next and actually see, well, where were we above or below our target? Well, then I can truncate the scale. Once again, I can start it at something other than 0. And many data visualization experts will actually say this is fine because it's not a bar chart. Personally, though, I wouldn't feel comfortable publishing a chart like this because it makes it look like our headcount was very volatile. But as we saw on the last slide here, it's actually incredibly stable. And it's hard for people to kind of mentally generate a sense of scale around this. Like, they can see there's some volatility, but how volatile is it? Well, I would have to kind of imagine what this chart would look like if the scale were 0. I kind of have to try and imagine this in my head, which would be very difficult, right? And so once again, we have a situation where we have all values falling within a narrow range. We want to feature those small differences between them. Inset chart to the rescue. Like I said, one of my favorite data visualization tricks. It doesn't just work with bar charts and line charts. We can do this with scatter plots. We can do it with maps, pretty much any chart type. So what are the key takeaways here? Well, when we have data where all values fall within a narrow range and we need to feature the small differences between them. Sometimes we do, sometimes we don't. Depends on the job of the chart. What is the main insight? But in these cases, you can consider using an inset chart. There's actually another very common scenario in which inset charts are very valuable, but I'm going to talk about those in a separate video. So stay tuned to YouTube or LinkedIn or wherever you're watching this video. If you want more tips like these, I will be teaching these and many other such tips in my Practical Charts course. If you're watching this before June 2nd, you still have time to register for that. I'm going to be delivering it live online. And if you want more information about that, you can find it all at my website, practicalreporting.com. Thanks very much for watching.